Unit 6, Lesson 9, Trigonometry and the Pythagorean Theorem. In a right triangle with an acute angle of measure theta, sine of theta is equal to 1/2. Draw the triangle and label the angle known side lengths. So there's my right triangle, here's theta, and opposite we know is 1 over the hypotenuse of 2. Next, we will find the exact length of the missing side of the triangle. So I'm going to use Pythagorean's theorem in order to find the third missing side. So I have the length of one leg as 1 square, plus b square is the other leg, is equal to the hypotenuse square, which is equal to 2. So b squared is equal to 4 minus 1, which is 3, which makes b equal to the square root of 3. Next, we're asked to find the exact value for cosine of theta. So cosine of theta is equal to the adjacent radical 3 over the hypotenuse of 2. And we're going to find the exact value for tangent of theta. That's opposite 1 over the adjacent of radical 3. I have to rationalize the denominator because we can't have a radical in it. And we get radical 3 all over 3. Tangent of theta is equal to radical 3 over 3. In a right triangle with an acute angle of measure theta, sine of theta is equal to 7/9. Using the same process as the opening exercise, what is the value of tangent of theta in the simplest radical form? So I'm going to draw a triangle, a right triangle that is, and I'm going to label opposite 7, hypotenuse of 9, using Pythagorean's theorem. I'm going to find the value of the missing length for the leg. So this breaks down to 16 times 2. So the value of the length of the other leg is 4 radical 2. So we're asked to find the value of tangent of theta. We know is opposite 7 over the adjacent 4 radical 2. Can't have that radical in the denominator, so we must rationalize it. And we get 7 radical 2 all over 8 is the value for our tangent of theta. In lesson 3, we discovered that x and y was equal to cosine of theta and sine of theta. Using this information, we are going to discover 2 more trig identities. So the first identity we're going to look at is the quotient identity, and that is tangent of theta is equal to sine of theta over cosine of theta. Okay, so looking back at the unit circle, we know that the hypotenuse, which is the length of the radius here, is always equal to 1. It doesn't matter where it is on the unit circle, hence the name unit circle. It's a unit of 1. You will always have a radius of 1. But when you drop a perpendicular here, you end up with a right triangle, and then we use the properties of right triangles in trigonometry to fill in some of the information. And it also creates more equations or formulas that we could use to solve for either different information or the same information. So I told you that the value of x and y is also known as cosine of theta, sine of theta. So this point right here is a point x and y. We're going to use cosine of theta, sine of theta. So cosine of theta, since it is x, that is the distance along the x-axis right here. And we can label it as cosine of theta. That's the horizontal distance. The other distance is right here, which is the vertical distance. We are going to label, and it runs alongside or parallel to y. That is sine of theta. If we label our angle in this little angle here, and we look at it in terms of tangent, we know tangent to be the opposite over the adjacent. Can you see that the opposite side right here is the sine, and the adjacent side to this angle is this cosine? So that's where we come up with this ratio, sine over cosine. As far as the Pythagorean identity is concerned, we know that the Pythagorean theorem is a squared plus b squared equals c squared. We can transform that to trigonometry to be, now that we have sides of the legs, sine square of theta plus cosine square of theta is equal to 1 square. If you simplify 1 square, it just results in sine square of theta plus cosine square of theta is equal to 1. So these are two formulas that you're going to have memorized. This one's the quotient identity, and this is the Pythagorean identity, so that you can use it and solve problems. So now we're going to redo the problems from the opening exercise in example 1 using the Pythagorean identity. So again, from the opening exercise, in a right triangle with acute angle of measure theta, sine of theta is equal to 1/2. Use the Pythagorean identity to determine the exact value of cosine of theta, and then use the quotient identity to find the tangent of theta. So we're going to do two things here. So we know sine square of theta plus cosine square of theta is equal to 1. I'm just going to write down what that identity is, and now I'm going to substitute. I have 1/2 as my value for sine. I'm going to square that. That's added to cosine square of theta, and that's equal to 1. So 1/2 square is equal to 1/4. That means cosine square of theta is equal to 1 minus 1 over 4. Which is equal to 3/4. Take the square root of both sides, and we get cosine of theta is equal to radical 3 over 2. If we look to the previous slide, you'll see that the value of cosine of theta is the same thing as the one that we did before. So now we need to find tangent of theta using the quotient identity. So we know that's sine of theta divided by cosine of theta. So we know sine of theta given as 1/2, that's divided by the cosine, which we just found to be radical 3 over 2. So you have a fraction divided by a fraction. That means you need to multiply the numerator by the reciprocal of the denominator. So we're going to flip it. The 2's cancel out, and what I have left is 1 over radical 3. But you can't have a radical in the denominator, so we must rationalize it. And we get radical 3 all over 3 is equal to tangent of theta, which is the same value we got in the beginning. So you can go ahead and check that at this time. So the next one. In a right triangle with the acute angle of measure theta, sine of theta is equal to 7/9. Use the Pythagorean identity to determine the exact value of cosine of theta, and then find the quotient identity for tangent of theta. So we're going to do the two steps that we did before using the same problem earlier. So sine of theta is 7/9, so sine square of theta plus cosine square of theta is equal to 1. I have 49 over 81 plus cosine square of theta equal to 1. Cosine square of theta is equal to 1 minus 49 over 81. Your calculator does that for you, so in effect we get 32 over 81. Now I need to take the square root of both sides, in which case I get cosine of theta equal to, no, square root of 32 you have to break down to 16 times 2, and the square root of 81 is 9. So if you do break it down to 16 times 2, which is highly recommended, you're going to get cosine of theta equal to 4 radical 2 all over 9. Now I have to plug it in to find the tangent. We know is sine 7/9 divided by cosine of 4 radical 2 over 9. I'm going to multiply the numerator by the reciprocal of the denominator. But now I'm going to have a radical in the denominator, which I'm going to have to rationalize. So 7 over 4 radical 2 times the radical 2 times the radical 2 is equal to 7 radical 2 all over 8. And we had gotten that same value earlier using the Pythagorean Theorem as well as setting up the trig ratios. So this concludes this lesson. Your responsibility is to complete the associated assignment.